needs. So any doubts so far in this? I mean, are you able to follow me in terms of SRE? I think I'm going too much technical, but I believe you're able to follow me now.
Yes.
Hmm? Okay. Yeah. Thank you. So now, since we are talking about this SRE, the reliability alert, so let's now see the core of the SRE. So what is one thing do you think that the customer expect from any service? It can be any application. It can be a banking app. It can be e-commerce website. It can be a healthcare system or whatever it is. The only thing that the customer expects is the reliability, because it's not just about performance. It's not about the efficiency, stability, or profitability, because none of these matter if the system is not available when the user needs it. Okay. We can tell. Okay, until I was a performance engineer, I was a performance tester, I used to think that the performance is very much important, because if the application is slow, um, the customers will get frustrated and they will never use it. But only after I became an SRE, I understood a, a harsh truth, that is, if the system itself is not available, then who cares about the performance, right? Who's going to care about the efficiency? If the system is not available, do you worry about the think time or do you worry about the response time? No, right? If you don't have a plate, then where will you serve? So that's how the reliability is. If you don't have an application itself, so that's the reason the SRE is very important, because the site reliability engineers focuses on the reliability, as that is the fundamental property of any SSP, that is a service system and product. So before you even think about the functional aspects, before you even think about the security, before you even think about the performance, you have to have a system, right? Until otherwise you don't have a system, where will you, or what will you do? What will you worry about? Why will you worry about the performance of that application, right? So the next thing is some of the reliability failures that you see here. So this you might have seen commonly, but many times we never bother about that, right? Because we don't think in a customer's point of view. But what happens when the reliability fails? So this is what happens. So seeing a blank screen from a failed PHP app, right? So what do you think this is? It might not look like much, but this is what a PHP app or PHP screen looks like when it crashes without a debugging support. So there is another one at the below or the bottom. You can see there is a failed Java application with a status HTTP 500 error. You must have seen when we are doing performance testing. So when we're doing a test, we might be seeing this error, right? So what does this mean? So each of these screenshots actually represent the application that likely took hundreds of hours and significant investment to build, right? It's not just about they don't come in a day or two. People have invested millions of money, hundreds of hours to build this. But if the application is not at all accessible when the user needs it, all the efforts that we do, that the operations team, that developers team did, all that efforts are wasted, right? And worstly, an unreliable system can lead to customer frustration. Yes, this is what we know. If it is not reliable, the customers will get frustrated, your reputation gets damaged, you get to see a lot of financial losses and operational nightmares as well. So to encourage, sorry, so to overcome all these, we need an SREs, and we have discussed it several times, right? Why we need an SREs? It's not just to fix the issues, but to proactively handle the issues. Yeah, I think, yeah, when reliability fails. So what happens when reliability fails, or why reliability is the fundamental property of the system? So let's put it in two perspectives with real world scenario. So AWS, we all know the Amazon Web Services. There was an outage in 2021. So one major AWS outage has affected millions of business, including Netflix, Disney Plus, who are using AWS, and a lot of banking services. So the loss of reliability had impacted thousands of users worldwide. So that actually happened in 2021 with AWS, the Amazon Web Services. And after that, I never have come across that. But yeah, that has happened in 2021. And then the Facebook outage in, again, same year, 2021. I think even recently also, I think I remember like few months back, I remember I was sending message and I thought, okay, my Facebook or my internet was not working. But what happened was the other side, the applications are down. So the Facebook, Instagram, and the WhatsApp went down for hours due to some internal configuration failure. I mean, you must have also heard about this, right? Some internal configuration failure that has brought down everything. So the businesses relying on these platforms for customer engagement faced lots of loss of revenue and trust because they must have paid for the advertisements, and uh, what if those advertisements were not being broadcasted to the people at the right time at the right place? So they would have lost revenue, right? So that's the reason. The third thing is the healthcare system downtime. So hospitals, we all know nowadays they are using our data, they are using a lot of systems and emergency services, which depends on critical software for patient care. So if electronic health record, we normally call it EHR. So if that system fail, it can even jeopardize lives. So it's very important. So the FHR, the EHR has to be reliable, and for that, the healthcare system should be reliable. So in all these above cases that we discussed, the Amazon Web Services issue, the Facebook outage, or the healthcare system issues, the problem was not with performance or with efficiency or cost cutting, right? It's not about performance. Nobody cared about the performance because the system is already down. Who's going to care about the performance? Who's going to care about the response times? It was the reliability failure. So the key thing is the reliability comes first. So without reliability, even the most advanced systems fail to serve the users when it matters. Right? The users wants to use something, but if it is not available, if it is not serving, then it is failed. Right? And the reliability affects the trust. If the application is not reliable, it affects the trust. It affects somebody's health, and it affects the user experience. And that makes the most critical factor for SRE. So now you must know how critical the SRE role is. And it's not just about fixing the outages, it's also about designing the systems to prevent the failures and ensuring continuous availability. Again, um, uh, reliability is the heartbeat of any system because without it, all the engineering effort, all the operations, all the effort that you have put, all the money you have put, the business strategy and user experience design, everything is nothing, right? If the system is not available, if the system is not reliable. So SRE, as an SRE, we should prioritize the reliability as the foundation upon anything that we build or everything that is built, right? So any doubts so far, or shall we move to the next slide? Okay, thank you. Yeah, so the next thing is what does the appropriate level of reliability really mean? So we all know, we think that, okay, there should be a balancing factor between the reliability and the speed, but what is that level? What do you think as the appropriate level? So the first thing is reliability versus over engineering. So a key principle in SRE is that not all systems need absolute perfection because it may sound counterintuitive, which is aiming 100% uptime is often unrealistic and unnecessary unless you're talking about life critical systems like aviation control software or like medical devices. Yes, when you're you cannot even give a point 0.0001 percentage in the aviation control or with the medical devices, right? Because that could be risking everybody's life who are in that system. But you can aim to reduce it to like 0.001 in other systems, for example like streaming services. And because a Netflix outage might frustrate like people like me, but it won't push any life or it won't put any lives at risk, right? Okay, if Netflix is not working, what I'll do is like I'll just switch off for some time and then I'll come back and then watch my movie again. But you cannot expect the same thing for a medical system because medical system failure in a hospital could be fatal and it requires 100% uptime. So the same thing, the goal in SRE is not chasing unrealistic perfection, but it is achieving the right level of reliability for business needs. So what happens is why the over reliability, or at which point does this over reliability gets waste or gets wasted? So just think of reliability as a cost benefit balance because the higher the reliability goal, the exponentially higher the resources which is needed to achieve it. Because what I'm saying is, if you want to achieve higher reliability goal, you have to maintain the resources for that. And if you want to maintain the resources, you have to spend a lot of money for that, because moving from 95% uptime to 99% uptime requires some effort. Because for example, take for example, like if it is like for 10 hours, if it is like 90% is like 9 hours availability, and if it's 95%, it's like 9.5 hours, so something like that. So 99% is like 9, close to like 9 hours and 45 minutes, something like that. But to maintain that 4 hours, you need to put some effort. And there is another way, which is moving from 99% to 99.99% takes a massive investment. So that's what I'm saying. Over reliability also can be wasteful, because chasing 100% uptime is nearly impossible, and also it's very very expensive, because you have to bring in more people, you have to bring in more systems, and it's also impossible, right? Because you don't get people, and you don't get people, you have to temporarily deploy them, and then you have to remove them if they are not required, because you will get budget issues and everything. So chasing 100% is uptime is completely impossible, and it's also not reality. In reality, it's not possible. So in reality, what the business does is they should optimize for realistic reliability, which is ensuring the resources are spent wisely. That's what I'm saying. So you have to use a resource, and they have to the resource has to be like used wisely, and then they have to be spent wisely while still maintaining the customer trust. That's what happens when it comes to the reliability part. And then the next part is SRE's pragmatic approach to reliability. So what happens is, now, okay, so far we understood that, okay, 100% reliability is not always necessary, and it's always not possible, because you're going to spend a lot of resources and a lot of money for that. So since you agree that, okay, 100% reliability is always not necessary, now let us focus on how the business determine the appropriate level for that. So what happens is, the business needs to dictate the reliability goals. So when I say dictating the reliability goals, they should come up with the reliability value or the numbers that should match the business needs. Say, for example, you're working for an organization where the customers connect through an unreliable network, that is 90%. When I say unreliable, they have an uptime of like around 90%. So the organization invest in making its service 95% reliable, but the network itself remains unstable. So that extra effort from increasing 90% to 95% is wasted, right? So instead, they could have kept the system at 90%, right? They don't need to waste a lot of money to improve the reliability from 90 to 95%. So whatever the extra effort, whatever the extra money they have spent, the extra time they spend, the operations, the developers spent on operations, and everything is wasted. So just to bring you a real-time example, just comparing about the airline booking system and a food delivery app. So airline booking system, they require higher reliability, as I told you, because the customer depends on flight schedules, and people might be traveling, so they might the aviation system has to be proper. But again, a food delivery app may not need to be near perfect uptime, because customers can wait, or they can use a different service. So that's the difference between the airline booking system and a food delivery app. So why are we talking about this? Because the business needs to dictate the goals, right? So the airline, they dictate their goals as they need to have a higher reliability, but the same level of reliability is not required for the food delivery app right now. So the reliability should be aligned with the customer expectations. That is, for an airline system, it has to be highly reliable, but food delivery app, it's not reliable, and the business value, and finally the technical feasibility. And then talking about the balancing of reliability. So when I say balancing of reliability, we need to check about the error budgets and the pragmatism, because SREs take this idea even further by introducing the error budgets. Because if a system is too reliable, are we like over investing in unnecessary maintenance, or if a system falls below expected reliabilities, how are we going to adjust that? So think of it like managing your phone battery. So in your mobile, we all have mobile, and we all have a battery for that mobile. So if you charge it only to 80%, that's often good enough for daily use. If you charge it 100% constantly, what happens is your battery gets weared out faster, right? So We keep on charging it like 100% all the time, and we think that okay, I'm going to keep my battery 100%. I'm going to use it all the time. No, your battery is going to get fast, weird out faster. So similarly, not every service needs hyper reliability. I mean, they're 100% reliability. So resources can be allocated strategically for what truly matters. So that's what happens when it comes to it. So the SRE focuses on achieving the right level. It's not the high level, but it's the right level of reliability, and it's also not about the perfection, because the businesses might align reliability with the customer needs, the technical feasibility with whatever they have, and the operational cost to maximize the efficiency and effectiveness. So by having a balanced reliability, or by having a right level of reliability, that is not the perfect level but the right level, the business can have their system reliable to the customers, right? So we saw about in the previous, we saw about the approach, and now we'll see about the achievement, like what are going to achieve, like the sustainability achievement. So just imagine you join your SRE team and you are getting a call at like around 3 a.m. to fix the system, like not just one day but every day, or like every night or every early morning at 3 a.m. they ask you to fix the system outage. So you barely sleep, right? And your personal time will get affected, your personal life will get affected, and you will be like completely burnt out, right? So now you're asking yourself, like, why you'll not ask that, okay, why did I join an SRE team? Will you ask that question, or will you ask, can someone in that state truly build a reliable system? So that should be the first thing that should come to your mind. Okay, so what should you think is like, why not someone build a reliable system? Because reliability is not just about systems, it's also about people. Because too often, very often, organizations focus only on the technical reliability and they forget the people behind the system, which is mattering too. Because we, the SRE engineers, also matters, right? If the engineers and operations teams are overworked, or they are stressed, or they're continuously firefighting, their ability to make meaningful reliability improvements drops drastically. So instead, what happens is, the real world example, I would say, uh, DevOps fatigue. I would define that as DevOps fatigue, because very large organizations like Google, like Amazon, they rely on reactive operations. Previously, they rely on reactive operations teams. Reactive operations. So when I say reactive operations, only when the issue comes in, they do react it. So what happens is, because of that, it leads to burnout and inefficiency. When I say burnout, they wake up early morning, they have like spending a lot of time sitting to fix the errors, they have wasted their personal life and everything. So instead of that, so that's how it actually went previously. So what SRE did for that is, like, they have changed the way they changed the way by emphasizing the sustainable practices like automation and smarter incident management, and thinking about another perspective. It's not just about only burning out the people, it's also about, we all know, we all have traveled by air. So peoples and air traffic controllers, they work under high pressure conditions, right? Because there are strict regulations which prevent fatigue driven mistakes, because there are a lot of mandatory rest periods, we all know. Because similarly, they do have, right? Because if they are like traveling for more hours, they have to they have to take enough amount of rest to bring them outside of the fatigue situation. So same way, the SRE also must ensure operational teams have balance so they can perform effectively and intelligently. So at this point of time, you must ask me, like, why the sustainable operations matter in SRE? Why the, the operations would be sustainable, or why uh, the sustainability operations are matter in SRE? Because if the people are constantly overwhelmed or they are burnt out, the systems also will suffer, because the SRE emphasizes the sustainability through these core practices, which is reducing toiling. I have told you again, toiling is one word that you will keep on hearing until the end of the session. So toiling is something you have to reduce. So how can you reduce that? Through automation. So you have to look into manual tasks, and you have to fix them, or you have to automate them. You have to manual tasks like repetitive incident response or like deployment should be automated, so the engineers can focus on system improvements rather than endless troubleshooting. And then the blameless postmortems, yes, instead of punishing an engineer for a failure, what the SIs does is they will encourage the learning from the incidents. They will create a run book. They'll create a lessons learned document to improve the future reliability. And then the error budgets, again, yes, the error budget should be there to maintain the work-life balance. So you have to define the acceptable failure rates that will prevent the team from overcorrecting any minor issues at the cost of their well-being. And then the next thing is you must have heard about the on-call rota. So on-call rota optimization also should be there, because if engineers constantly handle the outages, their long-term efficiency will drop. So there should be on-call rotations that help distribute the workload fairly. So it's not just the same person who should keep on working all the time. It should be like other people also should take the work on rotation. So just think of an athlete who is training for a marathon, right? So if they push too hard without any recovery, they should take some time for recovery, right? If they don't do it, or if they get burnt out before a race day, but with a balanced training, they peak when matters. So if they do practice and then they take enough amount of time for recovery, and they keep them away from burnout. They those athletes, right, with the balanced training, with enough break, they peak during the competition. So the reliability engineers also work the same way. The SRE engineers also work the same way. So they have to work, get trained, take break, and then they have to work again. So by doing all this, the SRE is not just about keeping the systems running. It's also about ensuring that the people behind those systems can perform at their best. So the sustainable operations prevent the burnout. Yes, because instead of keep on working, they take some breaks. So that will actually prevent them from burnout, and they have a clear mind, right? So they can improve the decision making, and at the end, they can ultimately enhance the reliability in the long term. So any doubts so far? No, right? Okay, thank you. And I'll paste, yeah, thank you. I'll paste a quick link. This is a short evaluation. Sorry, let me just quickly get that for you. This is so far. This is just about the topics with whatever we have discussed so far. Just take that assessment, and then we'll connect. Okay, I'm online. Just take that assessment. Now just check it if you are able to access it.
Yes, able to.
You're able to do, right? Okay, just take that so that we can understand how well I have explained SRE to you. Yeah, just let me know when you completed it. It's very simple. Whatever topics that we discussed.
Vasant, I have one question. So, some time back, remember there are certain updates because of which most of the systems were down, right? For example, the aviation, uh,
Hmm. Hmm.
they were not able to print the boarding pass or nothing, right?
Yeah, yeah,
But that happens because of certain updates, right? So,
yes,
will SRE could have been played a role in avoiding that downtime for those systems, or it
yeah.
is
If there
beyond that
is,
control?
yeah, if there is no SREs, then that is the issue. They could not have handled that. So for those systems, if they have SREs, then that issues could not have happened because they know what would happen if something goes wrong, if a deployment goes wrong. They know how to do a revert back it quickly. Like they know how to do a revert back so that at least they keep the system reliable and available for those users who are using it. Because they don't see, again, that's what I'm saying. Like they don't have a balance between the speed and the reliability. Because if the system is not at all available, then what's the use of checking about the performance, right? So that's the thing. So if the users if the application, if the business has SRE engineers, they will think, I mean, if after we join the team, we should think about that. That is maintaining the reliability and also maintaining the speed by doing the automation actions. And actually we should also find, like, okay, there is one thing that I have to teach you, I have to tell you, that's about doing the postmortem. Like, what if some issues happens, what if some issues happen, or what if things go wrong, how we should do a root cause analysis, and how we should fix it real quick, and then how we have to come out of it, like how we have to fix and bring the system out of it. So that's one thing. That's in fact actually a firefighting. But if you have a team of SRE engineers, most of the time it doesn't happen, because they know what is going to get blocked or what is going to get break, and they'll have a run book for that. If something goes wrong, follow this run book and you'll get it back soon. So we have to create those run books as well. And in fact, just to tell you, chaos engineering is one thing that will emulate that situation before you even get that issue in production. So that's some of the scenarios where you achieve all these even before you deploy your system into production.
Okay, good.
Yeah. Okay. Thank you. Yeah. So far I've got two responses. They could. Uh, yeah, I could see. Mayur, are you there? I could see Priyanka and Anshul's responses. Mayur, you there? Hmm. Fine. No worries. Let him come. But yeah, I mean, let's continue. And yeah. So I've sent you your scores. You just check that. So about the question and answers, let me bring to the screen here. So I could see for this one, the first question, that is, which property of a service, system, or product does SRE focuses on? So yeah, the SRE. I don't know why I've kept it twice, but yeah, again that's right. But again, SRE primarily focuses is on indeed and reliability. So yeah, that's also right. But again, this is the right answer. That is, the SRE's primary focus is on reliability. And the next thing is, for almost all the services, the SSPs, I would say, system services, system and product, what level of reliability does an SRE strive for? So here, the first answer was like setting a goal for a services collaborative effort between SRE development resources and the business decision makers. No, that's not the right answer, and it should be as reliable as possible. No, I have mentioned this word, that is a specific level identified as appropriate. So you must have removed that word, right? The appropriate level. That is what is required for the stakeholder. So we have to maintain the appropriate level rather than as reliable as possible, because that's they will expect close to 100, which is not reliable. So here I could see one right answer. That's good. So why is achieving 100% reliability often desirable for most systems? Because yeah, that's right. It requires excessive resources. Yes, it requires a lot of people, a lot of system, and in turn, yeah, it will not have a lot of cost that may not align with the business needs. That's right. And then what does the term sustainability refers in the context of SRE? Yep. So I've got one right answer. It's great. So that is creating operations practices that prevent the burnout and support engineers. Yes, I think we have seen it very clearly. That is, sustainability does not mean only about the application. It's also about the people who gets burnt out, and also it's supporting the engineers' well-being. Yes, that's right. And yeah, what's an error budget in SRE and why is it important? Yep, a defined acceptable failure rate that balances the reliability and innovation. Yes, that's very right. That's very correct. I think both of you have answered rightly. And then the last question, which of the following practices will help ensure sustainable operations in SRE? So yep, that's right. So automating repetitive tasks to reduce the toiling, that is reducing the manual work. Yep, that's right. So yeah, with
But
that we'll come to an end. Yeah, go ahead.
the last question, like, this is also like on-call rotation is also we follow to sustain in SRE.
On-call rotations, you should not increase it. Instead, you
Uh,
should decrease it. Right? The people have to be continuously rotated. So you have to decrease the on-call rotations, and you are not supposed to give more incidents to them, because at the end of the time they'll get burnt out, right? So you must reduce the on-call rotate. So you must reduce the on-call. I mean, you can increase the on-call rotations, but that means you have to reduce the incidents for them. They're not supposed to handle more incidents, right? You got it. You got the balance between it. So you have to increase on-call rotations for people. Yes, I agree, but that should not handle more incidents. It is not to handle more incidents, but it is to handle less incidents. So that's the reason I kept that here. Okay. Yeah. Okay. Thank you. Thanks, Priya. Thanks, Anshul. And yeah, I think Mayur is on mute. Fine, no worries. So next week we'll see another topic. I think next week we'll start with we will try to cover a little bit of SRE topics like what we discussed so far, because I think so far what we discussed, do you really think that it benefited you in terms of understanding what the SRE does? And do you really think that, okay, I can be suited, I can be like from day one, I can turn myself into an SRE engineer. So do you gain that confidence with the session so far, whatever I have took? I just want to understand that.
Yes, definitely.
Yes, definitely, Usman.
Okay, okay. Thank you. Yeah, because that's the level of confidence which I need, because it's not just about only learning it and only about clearing interviews, but once you start moving into the team, you have to be reliable. You have to be like ready to start your work. I think Mayur also has updated. Yeah, thanks, Mayur, for your answers. Yeah. So yeah, so next week, going forward, we'll touch base on some of the topics of SREs, and then we'll touch base. So going forward, we'll start looking into Kubernetes, YAML, Datadog, and there is one more important thing, which is the open telemetry. Anybody as a SRE must know that. So we'll go into touch SRE, the open telemetry part, and then we are also going to see about what, with one of the tools, we're going to see about the chaos engineering as well. So these are the upcoming plans which you're going to see. And I just again am reiterating, just go through all the videos, just go through the GitHub and everything. If you have any doubts, just let me know, keep on practicing, and then yeah, we'll meet next week. Okay.
So it is shared on that SRE live training group only, right? The videos?
Sorry.
The
Uh,
videos?
if you are into the training, if you are into the yesterday video you're asking about, right?
Yeah. No, I'm talking about the videos which were, I mean, the videos till date for the training.
If you're into the group training, you must be able to access that.
Okay.
Anyways, I'll share the playlist. Yeah, I'll share the playlist with you so that you can
Okay.
watch that.
Okay. Sure.
Yeah, sure. Yeah. Yesterday video I'll share, and today's video also I'll share it shortly. Yeah.
Yeah, I have one doubt. Uh,
Yeah, please.
yeah, actually, I was going through the first video. Okay.
Mm-hmm.
Just I'll share my screen. Can I share my screen?
Mm-hmm. Mm-hmm. Sure.
Let me know once.
Yeah, sure, sure.
Is it visible now?
Yeah, I can see now. Yeah. Please.
Okay, okay. So actually, I was going through the first session
Mhm,
where
mhm,
we used to push this any changes in the README file to the GitHub. Okay.
mhm,
So like I pulled this request here. Okay.
mhm, mhm,
So that's it. Like in this way, like I'll be able to do the changes that I had done in the README file. Like I added
mhm,
to
mhm.
here.
Okay.
Or like, can I see that changes, or is it required your approval as well to do?
Can you click on the pull request for me, please? The click on added and should click on add. No, no, no. The pull request. Yeah, you created.
Pull request where?
Yeah, no. Can you see added Anshul, the pull request that you created?
Yes, yes, yes.
Yeah, click on that. Click on that. Can you click on the files changed on the tab at the top? Files changed. Yeah. Click on review changes. Yeah, thanks, Priya. Yeah, take care. Bye. No, no, no. You don't have access to it. Let me do it. Just a moment.
Thank you very much, Basant. I'm also
Thank you,
dropping.
thank you. Yeah,
Yep.
sure. Thanks, Samir. Yeah, take care.
Bye.
Yeah, bye.
So basically, it's your like this repository you have created, so
Mm,
only you
mm.
will be able to do the change review,
I'm
correct?
the owner of it. Yeah, anybody else. I
Okay.
mean, you cannot do it, but anybody else other than you can do it. So which is what is a repo? Okay, I think I must see the
Okay.
in which repo. Okay, you are doing into SRE training, right? Okay,
SRE
I
training.
just
Yes, yes,
one. Yeah,
yes.
yeah, just getting it. So SRE training, I'm the owner of it, so only I can approve the request. Other repos, yeah, I can create your own repo and then you can make the changes. So that should not be a problem.
Okay, okay.
Let
But
me go to files
this is the logic,
changed.
na? Like whoever has created the repo, like I'll not be able to do change approve
No, whoever
other
create
than
the
me.
pull request, yeah, whoever create the pull request cannot approve it. Yeah, that's right.
Okay,
Owner
okay.
can do it, but yeah, the one again there is no use of it, right? If you are creating the pull request and if you are reviewing it, so you might miss something.
Yes,
So
yes.
that's the reason we bring this logic. So some peer or some colleague has to review that. Yeah, now your
Hmm.
change has been approved. So now it has been running. If you check in the actions, you can see that. Yeah.
Other than me, anyone can.
Okay. Yeah.
Where in
So now we
actions?
can see your change has been merged. So if you go to code, go to code. Yeah. And click on yeah readme. You can see your line. See merge this branch.
Yes,
Yeah.
yes.
Yeah. That's right.
Okay,
Okay. Yeah.
okay,
Try
okay.
other
Sure,
things also and let me know. Yeah. Thank you. Thanks so much.
sure, sure. Thank you. Bye.
Yeah. Thank you. Yeah. Take care. Bye.